Good morning, I'm Yongliang Zhang from the Department of Hydraulic Engineering, Tsinghua University. My research topic is study on key technology of pneumatic wave energy power generation. First of all, I'd like to introduce research background. The most unstable marine energy is wave energy. The wave energy conversion system faces great challenges in efficient operation under normal sea conditions and reliable survival under severe sea conditions. The development of its strategic emerging industries has become the commanding heights of science and technology that coast countries are scrambling to seize. It has irreplaceable important application prospects in the fields of basic science, marine economy, and marine homeland security. The research on wave energy power generation technology has a history of nearly 100 years, especially in the past 30 years. Wave energy utilization technology has rapidly developed, and hundreds of structure types of wave energy conversion devices have been presented. These devices have been applied for grid connection or independent power generation. Here are the 12 most representative wave energy conversion devices in the world. These devices, according to their structure types, are mainly divided into oscillating water column type, point absorption type, pendulum type, loft type, and pressure difference type wave energy conversion devices. According to its energy transmission mode, it can be divided into pneumatic transmission and hydraulic transmission. At present, wave energy power generation technology is still an emerging technology, and its main development trends are divided into two categories: pneumatic transmission and hydraulic transmission technology. Hydraulic transmission technology uses relative motion between the floating bodies and the supporting platforms to achieve wave energy conversion, which means that the devices of hydraulic transmission technology is composed at least two or more structural bodies with large-scale, high-ocean engineering costs, high implementation difficulty, and poor reliability. The pneumatic transmission technology mainly drives air turbines to rotate by shaking the device and the action of waves, causing water column oscillation and periodic changes in chamber pressure in the L-shaped flow channel. The device of this technology is single body, with relatively simple structure, low cost, and high reliability. This single floating device has been operating stably at sea for more than 2 years and have withstood the test of large waves, and their cost effectiveness is significantly higher than that of multi-structure devices. Therefore, pneumatic wave energy converter has obvious comprehensive advantages and broad development prospects. For backward band duct buoy oscillating water column pneumatic wave energy generation device, a fully coupled model theory from waves to electricity has not been established so far, making the mechanism of fluid-solid mechanical-electric interaction in the device unclear. Additionally, the efficiency of air turbine in the device is not high enough and the survivability is not strong enough, these will be the problems we need to solve. 3. Theory development for pneumatic wave energy converter. In response to the problems of frequent extreme typhoons, poor sea conditions, low wave frequencies, and large fluctuations, existing models are difficult to accurately simulate this kind of problem. The simulated results using the existing model will differ by up to 100% from the actual measured ones. The common equations for fluid, structure, turbine, and generator motion are used to develop a fully coupled model of the backward band duct buoy pneumatic wave energy conversion system from wave to electricity. To make up for the significant deficiencies in the theoretical errors of existing models, and to clarify the mechanism of fluid-solid mechanical-electric interaction in the entire system from waves to electricity. Compare the chamber pressure and turbine rotational speed obtained from the established model with the experimental results respectively. The left figure shows the variation of non-dimensional experimental and simulated chamber pressure over time, while the right figure shows the non-dimensional measured and simulated turbine rotational speed over time. The maximum relative error between the experiment and the theory is about 4%, which verifies the effectiveness of the present model and make up for the significant theoretical error of the existing model. The left figure shows the capture radius ratio of wave energy captured by the device and the different degrees of freedom motion and conditions. It can be seen that the contribution of the device surge to the capture radius ratio is absolutely dominant. It is also found that the frequencies of surge, heave, and pitch are different, leading to the superposition effect of water column oscillation waves in the channel. The right-down figure shows the variation of the capture radius ratio, turbine efficiency, and total device efficiency with wave period, which shows by model phenomena and the device's response, wave frequency band becomes wider. Due to the difficulty in the further improving capture radius ratio of existing backward band duct buoy oscillating water column, pneumatic wave energy converter, ball bottom water pressure plate, and ductile guide plate technologies are proposed. The left figure shows the variation of capture radius ratio with wave period for the device equipped with a ball bottom water pressure plate. The wave energy capture radius for the device with a ball bottom water pressure plate is 14% higher than that of the traditional one. When the capture radius ratio is equal to 70%, the frequency response radius of proposed device is 27% higher than that of traditional one. The right figure shows the variation of capture radius ratio with the period for the device equipped with a ductile guide plate. The capture radius ratio of this proposed device with a ductile guide plate is increased by 17% compared to the traditional one. And when the capture radius ratio is equal to 70%, the frequency response radius of proposed device is increased by 30% compared to the traditional one. The addition of water pressure to plates and ductile plates implies that the device can significantly increase annual power generation. In order to effectively reduce the aerodynamic energy loss at downstream row of guide wings, an impulse air turbine with fixed U-shaped flow channels and dual radial flow was invented, with an efficiency increase of 66%. The numerical results of transient simulation of U-shaped impulse air turbine indicate the pressure and flow rate do not meet the quadratic relationship of existing theories, and the existing steady-state design theory overestimates the turbine efficiency. The air turbine developed has been successfully applied to 30 kW pneumatic wave energy conversion device and has been verified by offshore tests, which has solved bottleneck problems of low efficiency of air turbines, which restricts the development of vapor utilization technology. Main factor affecting the viability of the floating pneumatic vapor generation device is the anchor chain load, and one of the main factors determining the anchor chain load is device load. However, the existing vapor generation device structure itself is difficult to significantly reduce the device load under high sea conditions, and it is difficult to further improve the device viability. The Invention device automatically reduces the air chamber pressure to release the vapor captured by self-protection system. In high sea conditions, the device can automatically release up to 90% of the energy captured by the device, and the device load is reduced by 86%. The laboratory scale and prototype test results show that the anchor chain load is reduced by 85%, realizing a major breakthrough in the survivability technology of the device and the anchor system, and ensuring that the offshore test device is safe in typhoon. 4. Conclusions. Now let's summarize what we just talked about. The coupling model of the whole pneumatic wave energy conversion device from wave to electricity is established to fill the gap in this field. The capture radius ratio increased from 90% to 103.3% by 13.8% by setting up water pressure plate, while the capture radius ratio increases from the 117% to 138% by 17.9% by setting a ductile deflector. A normal U-channel impulse turbine is presented, and the turbine efficiency increased from 53% to 66%. The overall efficiency under rated conditions is 42% to up to 53%, increases by 26%. A strong survival technology that releases energy from the wave energy converter and absorbs energy from the anchor system is presented to jointly reduce load by up to 85%. I have finished my report. Thank you.